Hello, welcome to my tech fun. Creality sent me K1 3D printer for the review, and this is Creality's coreXY printer, some kind of answer to Benchy printers, but this has great specifications and very good price. 600 millimeters per second is the maximum speed, 20,000 millimeters per square second the acceleration, 32 cubic millimeters per second the maximum flow rate or the hot end, which can be heated up to 300 degrees Celsius, and it is fully enclosed with the big screen. And I think this is the main reason why the Bambu Lab launched P1S printer, because with P1P they had a similar price, but P1P don't have the enclosure and very small screen, textile screen. Now the P1S, it has the enclosure, but still have that small screen and higher price. Other specification: hands-free, auto leveling, accelerometer built in the head, so we can do that input shaping and have that faster printing without ringing or ghosting, and similar specifications you can see on the website. And I will start the printings with this Hyper PLA because I tested it on Ender 5S1, but this is much faster printer and I hope it will have nice printings with this filament too. Now, I wanted to start here this recording because I'm curious that every printer arrives in this wooden box. I'm not sure. This is how I got it, so let's see what's inside. I think the early packaging was without this wooden box, but after several broken glasses, I think they decided to protect it much better, and this is maybe overkill, but definitely good packaging. Well, this was inside, some rubber legs, a spool holder. This is the screen, and with the warning to check the voltage if it's set correctly for our country. Sample filament, and it is on spool. That's very nice, 200 grams of PLA. And then we have some tools, cables, and this is the top cover. User manual. This is the drag chain, and probably it has to be separated here, but this one looks like it is broken, but maybe it's not. I hope not, so I'll just try to connect this. Okay. This is the left side of the printer, and I can see in my case the voltage is set correctly. After checking the voltage, the next step here on the screen is to remove these 3 securing screws. It is very easy to find them because they are marked with these yellow arrows. 1, 2, 3. According to user manual, the next step is connecting the screen. Installing the spool holder on the back of the printer. So the filament goes on this holder, and from here it goes inside this filament runout sensor into this drag chain and to the hot end. Another thing I can notice that these rods for the x-axis are from metal and not from carbon. This is the top cover and it goes here, but we have a warning that not to use it if you are printing PLA or similar materials because it needs more cooling. It is very useful if we are printing ABS or similar materials, then we need some higher temperature inside the enclosure. Now I notice that this sample filament is also Hyper PLA, like this one which I will use later. I will start with this one, but white color is not too good for the camera, so I will start the first printing with white color and then I will switch to red one. I can see this is some kind of smooth PI sheet. Oh. Please apply glue before the print. Okay, and where is the glue? Well, I couldn't find any glue in my package, so I will just use this one. This arrived with some procurement filaments. This is PVA-based glue, and I like to use PVA-based glue sticks because it can be easily washed with the water. It's water-soluble. Interesting that this holder is not mentioned anywhere in the user manual, but I believe it's quite obvious that it has to be mounted to these doors. Feels good, but for first printings, which will be from PLA, it will be opened. It's almost ready. One important thing. I just turn on the machine. Let's choose English, OK. Yes, I removed those 3 screws. Connecting to network. I have to scan this QR code with the Creality Cloud app, but I have a problem that this app won't work on my device. Maybe it's time to replace my smartphone. Let's try my wife's. Well, this is some kind of Samsung, and here it will work. Install. Now let's scan the QR code. When it lifts up, then I can take out the rest of the black foam below it. This is it. We can follow the self-test on the screen, but I think I don't have to do anything so far. It started with some vibrations, and that's the input shaping, and don't be scared if you didn't hear this earlier. So this is normal, and it will do it in X and Y direction. It finished the input shaping and also the auto leveling, and maybe now it is testing the fan, and it will be a very loud machine, unfortunately. Self-test completed, and for this it needed approximately 10 or 12 minutes. And now I can see that clipper screen, a little bit modified of course. Unfortunately, the application is full of annoying ads, so I decided not to use it. Instead, I need this IP address, and I can enter it into my browser on the laptop or tablet, and then I can control the printer over the network. Or I will show you later, you can send the printing directly from the Creality Print slicer. And now it's time to preheat the nozzle and insert some filament, and I will do some test prints which were prepared by the Creality. Applying some glue on the smooth print surface, inserting the USB drive, and between these files I can see a Benchy. First prints, and first layer looks okay. Oh, now all fans started with the working. I think this is the third layer. Very fast and very loud printer. And it's printed in 17 minutes. Immediately I want to check the bed adhesion. Oh, which is good. Not sure do I have to wait until it cools down or I have to flex it. I will wait anyway 5 minutes. Even now when the bed cooled down it sticks very good, so I have to flex it. So this is 17-minute Benchy and it looks fantastic. Perfect first layer. I cannot see any ghosting or something like that, no stringing at all. Great job for this first print, but it's time to prepare the slicer and slice my own G-code. On USB drive you can find the Creality Print slicer, but I better like to use the latest version, so I downloaded it from Creality's website. And I inserted the STL file, D6 calibration cube, and I already entered the IP address in slicer, so I'm able to upload over the network. Here I can do some additional settings. I'm changing the infill density here. Slicing, this is the preview, and I have the option I can save the G-code and upload it to printer, or I can send the job directly over the network. The quality is great. This is the x-axis and this is the y-axis, and I cannot see any sign of the ghosting or ringing, and this is the z-axis. The top surface also looks very good, and this is the bottom layer. It is very smooth, and to be honest I better like the textured PI sheets and that kind of surface, but this also works great, but I have to use the glue stick. And it's time to change the filament, and the retraction will be done automatically with the preheating. And I'm moving to the red color, Hyper PLA. As always, I'm missing a metallic tweezers from the package. My next test printing was in spiral or vase mode, and usually the clipper don't have problem with this kind of printing, First I thought that it is a little bit too fast, and then I decided to slow it down a little bit, but then I realized that I cannot do it from the screen, and I asked the Facebook group, so they confirmed me that from screen we cannot slow it down. Only over the web interface I can do it if necessary, but then I decided to leave it as it is on 100% and to see if it will be finished, and it was printed correctly. This is a phone holder printed in vase mode. Printing is finished in 29 minutes, and I hope the layer adhesion is better than the bed adhesion and it will not break when I start with the flexing. Okay, it's fine. Well, I was afraid that it prints too fast and I wanted to slow it down, but it looks okay to me, but I think it's time to check the layer adhesion too. I'm printing 4 test objects at once, and also I'm printing the dice in the middle because I don't want this printing to slow down because of that minimal layer printing time. The printing was without any problems and it was quite fast. And here I have these 4 test objects prepared for the testing inside this holder, CNC machined by PCBWay. And the average 51.8 kilograms. They look fine, but let's check the numbers. Let's analyze the data in this Excel table, and here I include the results from my previous hyperpiller review video. Those test objects are printed on Ender 5S1. And here you can see, even if those test objects are printed on a little bit lower temperatures, but much slower, I got better layer adhesion. But we don't have to worry because this is still very good, and you can see it is better than average PLA using these test objects. But let's measure the maximum flow rate now. This is the automatic flow rate test developed by Stefan from CNC Kitchen, and I'm doing this on 2 temperatures, and I can clearly hear the skipping over extruder on higher flow rates. And after this I'm measuring these small poops one by one. This is the weight in grams. I'm using here this jewelry scale. These numbers are in grams, but let's analyze it on the graph. And from this I can clearly see that printing on 220 degrees Celsius, this hyper PLA, the maximum is approximately 22 cubic millimeters per second. And if I raise the temperature to 240 degrees Celsius, the maximum is approximately 26 cubic millimeters per second. In both cases this is below advertised 32 cubic millimeters per second, but let's see what can we do with these numbers. This hour will be my next printing, and I already checked the outer walls are printed maximum at 17 cubic millimeters per second, but inner lines are always printed faster, and here approximately 21-22 cubic millimeters per second, so we are very close to the possibility of this nozzle. Only later I noticed this table, and look at this. Hyper PLA, the maximal volumetric speed in cubic millimeters per second is 23, very similar to the value which I measured. Here I will insert a few seconds of printing in real-time speed so you can see or imagine how fast is this printer. Only thing I will do is reducing the background noise. Last time I printed this on Ender 3S1 and the printing time was almost 6 hours. Here it was finished in 1 hour and 45 minutes. And the quality is great, only I hate this glue on the bottom surface. Let's see if this will work. This is from Ender 5S1 textured PI sheet. It has the same size and also it has these aligning pins. And I will test it as it is now without glue stick. This is still the first layer and the start looks okay so far. And now I notice that the bed temperature is 45 degrees Celsius, which is actually designed for that smooth PI sheet with the glue stick. I hope it will be enough, and actually I hope also that it will not stick too good, because now the nozzle may be deeper in the material. Oh, and now it starts with the other fans, maybe too noisy for the background. The printing is finished, the bed is 39 degrees Celsius. And now let's see how easy it is moving the object. Perfect. And does it work? Great. Seams line is a little bit more visible than I would like to see it, but otherwise, great printing. Currently, I'm not really sure what is the advantage of the smooth PI sheet, because here we don't have the LiDAR sensor, which would require maybe a smooth surface, and I better like a texture PI sheet. Well, probably I buy one for my K1, and I'm not sure, maybe this is good for some high temp materials and it will stick better. Not sure. What is your experience with this? Anyway, the smooth PI sheet goes back to K1, because this go back to my Ender 5S1. In my next test, I want to print something which will use the whole surface of the bed, and I will print it from this green PLA. This is completely ordinary PLA filament, 3 years old. And first I want to do some flow test, because I'm curious what is the maximum flow rate with the regular PLA compared to the hyper PLA. Interesting analyzing these numbers in these two columns, which are printed on same temperatures, and also on this graph I cannot really see the advantage of the hyper PLA, but good news is that I don't have to slow down if I want to print with this BQ filament. Preparing for the next printing, which will use almost the whole surface of this print bed. This looks like a drawing with a pencil. Great first lines. A perfect first layer for each element on this build plate, and this was fully automatic bed leveling. And usually I print these objects on my workplace on NS3V2, and for 8 pieces I need 2.5 hours. But here I have 24 at once, and they will be printed in 1 hour and 45 minutes. These are key holders for the shopping cart coin replacement. And I'm printing this for my university with our logo, and this is for some kind of exhibition. Have I mentioned that I hate to use the glue stick? At least for PLA. And now I want to print something from Creality ABS, because this is enclosed printer, and I will use the generic ABS profile in the slicer, and also I would like to try to measure somehow the temperature inside the enclosure. And there is the position of the sensor, and I hope it will not be in the way of the drag chain or this Teflon tube. The start temperature inside is 23 degrees Celsius, and I will record the temperature every 10 minutes. The bed was heated up to 100 degrees Celsius in 4 minutes and 15 seconds. The start is good, the first layer lays down correctly, and the temperature inside the enclosure is almost 40 degrees Celsius after 6 minutes. This is the torque wrench for the nozzle, and I already printed one earlier from PLA, but once I forgot it in my car, and it wasn't too hot day. But since that, instead of 2.5, it keeps on 1.2 Newton meters. And one more thing I noticed, that it is great that it has these LED lights, but as you can see, the nozzle is in complete shadow, because the light is here. It would be better if the lights are somehow lower, maybe from two sides here. This is a little bit confusing, so the printing time is 1 hour, and the renaming time is 43 minutes, but the printing is at 50%. And also this picture is a little bit confusing. It would be more accurate if this would be a front view. In that case, this status color changing would be accurate. Printing is almost finished, 10 more minutes, and the temperature stabilizes around 61, 62 degrees Celsius approximately. Now it almost jumped one. And this is far enough for the ABS, maybe even for some polycarbonate. Of course, don't forget the sensor is now on the top of this chamber. Of course, the real temperature we would like to know where is the nozzle, but maybe it is 2 or 3 degrees smaller. So approximately 60 degrees Celsius inside the chamber. The bed cool down, it is 33 degrees Celsius, and now let's see how easy is removing the object. Thanks to the glue stick, it sticks very good, so I have to flex the bed. So I noticed that it leaves approximately 35% part cooling, and looks like the layer adhesion is now a little bit weaker. Actually, the bed adhesion is bigger than the layer adhesion. I have to check this, but not in this video. And just a quick test. .4 Newton meters, perfect for the nozzle. Analyzing the graph, we can see that it reached the 50 degrees Celsius inside in less than 20 minutes, which is good basically because don't forget you can print ABS even without enclosure if the object is smaller, because on lower Z coordinates it is heated by the 100 degrees Celsius bed surface. After 1 hour, the temperature inside the enclosure was above 55 degrees Celsius, and in 1.5 hours, the temperature inside the chamber was above 60 degrees Celsius, and it looks like it stabilizes on this temperature. There are a few more chapters, so don't go away. What I like with this printer? Well, I like that it is fully enclosed, it is fast, the nozzle can be heated up to 300 degrees Celsius. I also like the price, this nice big touchscreen. It is also fully assembled and completely automatic bed leveling. Now, what I didn't like with this printer, well, for some reason the new trend is that they placed the spool holder on the back side. Also the Bamboo Lab, the QD and other printers. Not sure, maybe their laboratories have the desk in the middle of that room, but most of the users place the printer next to the wall. And it is a little bit uncomfortable to approach to the backside to change the spool, insert it into filament sensor and similar. It's loud. When it is closed, then it reduces the noise to 6-7 decibels. But don't forget, with PLA you need this opened, and in that case it is loud 65 decibels, I think I measured. I hate to use the glue stick, even for the PLA. Okay, I understand maybe with some high temperature technical filaments I have to use it, but with PLA, so definitely some kind of different PI sheet would be better here, especially we don't have the LiDAR sensor which requires the smooth surface. The screen, it is great, very nice for the touch and for the look, but I think some things could be changed there. For example, I'm missing here the speed settings. I cannot change it from the screen, only over the web interface. It would be good to see the current Z coordinate on the screen, and colors should be thinking over, because it's a little bit hard to see the time with that dark gray color. And the preview image is a little bit confusing because it is under 45-degree angle and it's changed the colors, but if they want to use this kind of display, then maybe the front view would be better, and in that case that color changing would make sense. Drag chains sometimes hit the top cover, and I'm not sure, is it a problem or do I have to fix it? What's your experience about this? Plan upgrades. 3 upgrades you can buy, and I will buy it myself. The first one is the camera. The second is the nozzle kit, because it arrives with the brass nozzle, but it will be good to have some harder nozzle, maybe some different diameter, textured PI sheet, and maybe you can write me some suggestions. There's a few things which can be printed. One of them is a 270-degree angle hinge, because this door can be opened here, and maybe it will be in the way or something like that. So there is a solution already that it can be completely open and it will be next to the printer. I already saw that there are some solutions where the spool holder is on the side. I probably have to move only the filament sensor, because in most cases I would like to use some kind of filament dryer, and it has its own rollers, and it can be on the side. And also I can see that some users place the Teflon tube outside of the drag chain with some holders, but in that case some kind of razor for this top cover is required. I'm not sure, I'll leave it as it is now. For me it looks okay so far. And for the end, K1 versus P1S Bamboo Lab printer, because I think this is the main competitor to this printer. Well, first question, what size do you need? Because this size is 220 millimeters in X and Y direction, the Bamboo Lab is 256 cubic, or maybe you can go immediately with the K1 Max, which has 300 millimeters in X and Y direction. Next question, do you need a multicolor printing? Because currently the Creality don't have their own solution. I heard some rumors that they are working on one, but when will be it finished, I'm not sure. So the Bamboo Lab has the AMS, and but don't forget, I don't really use that AMS system too much, because extremely lot is that vase material when we are printing in colors. The screen, well, P1S from Bamboo Lab, it still looks, I don't know, cheap or something like that, with that small textural screen. And I know it's all about the money to motivate the people to buy the, I know, X1, but it's very cheap. How do I know? Well, take a look, A1 from Bamboo Lab. $240 or $250 price, and it has a nice color touchscreen. So why don't they place something similar on P1S? The price motivation to buy the X1. And of course, the price is better on the K1. I already mentioned that. The slicer for the end, well, to be honest, I like better the bamboo slicer. Maybe I get used to it already, but I noticed some smaller bags with Creality's new Creality Print slicer, and I believe by time it will be improved too. This is my experience. Well, of course, I'm using this only maybe a week or two. If you have some additional comments, drop a few lines down in the comment section. Thank you for watching and happy printing.